Now we are trying to understand the LCD drawing. The LCD drawing, for the first look, it can be a pretty complicated, but actually it isn't. So let me explain one by one, from top to bottom. So here, actually, as we know, liquid crystal display, LCD liquid crystal display need to have uh, liquid fluid that is injected into the cell. So in that case, after inject, we need to have some glue to glue the end. So that's why there is a bump here. So that is a 10 millimeter maximum size, and the height is 1 millimeter max. And for the from the left side, so we see the LCD have some corner here. Actually this is LCD, overall direction, and actually this traces actually for contact points, for ITU contact points. Okay, so this LCD have a two corner cut to fit into the housing. So this dimension is a dimension for the cutting height, and uh, this dimension that is from the middle of the first trace, for the first ITO context to the middle of the last ITO context, and this 1.00, that is a width and a gap of the ITO traces. And this dimension actually shows the last, in the middle of the last uh, ITO contracts to the edge, the distance. And for the right hand side, we can see that um, this is also the ITO, from the first, middle of the first and the last ITO traces the distance. And this 68.58, that is a viewing area. That is a viewing area. Actually, there is the viewing area. It is pretty tricky. Actually, the most of the customer will depends on the viewing area to design the housing window, and the window cannot be too bigger than the viewing area. Otherwise, some ceiling on the edge of the LCD will show up, and it cannot be too small. Otherwise, the housing can block some display contents of the LCD. And that is a POL. That is means the polarizer size. We know the front and the rear. We have a polarizer, two polarizers. So that is a dimension, and the last one is outside dimension. It is also have plus minus 0.20 tolerance here, and here is also the polarizer height. Yeah, and and uh, and its tolerance here, and because most of the polarizer are attached either by manual or by machine, so there is a big tolerance of attaching the polarizer on the LCD. So the tolerance is 0.5 plus minus 0.5 on both sides of the polarizer. And we can see that there is a pin here. We can see the pin width uh, is 0.5 width here. And it's the same thing here. And if it is from, this is a front look of the LCD. If the from the side look, and we can see that it is a front polarizer and a back polarizer, and it's a polarizer attaching tolerance here, and this is a pin thickness is 0.3 here, and the distance between the pins is 86.56, and this is also tolerance here, and this dimension is a pin height, beneath the LCD, so we can see this is also the big tolerance here, and 1.0, that's the thickness of the glass, not including uh, the the polarizer. Actually, the maximum thickness of the LCD is 2.80. At the bottom, we can see that this is a viewing rule, and this is a viewing direction. From the bottom, we know that it's the 6 o'clock, and we see that it's a part number, and it's a TN positive. It is 6 o'clock, reflective, and the operating voltage is 3.3 volts under 75 hertz, and this is the operating temperature and storage temperature, and this is version recording. That is very important, to avoid any mistakes, and who designed the drawing and the date for the drawing. Oh, that's the end of the video.